Afternoon and welcome, ladies and gentlemen. Thank you for joining us. My name is Fasi Qureshi. I'm the General Manager at Informa Connect Academy. It's great to have you all joining us today. We've got Dr. Frank back again to deliver another impactful webinar. So we're very excited, and it's good to see you, Frank. How are you doing?
Good. Thank you very much.
Fantastic.
I hope everyone's well as well. My apologies to the people in Europe if anyone are on the call for the early start time. We're working on that. The next one will be a bit later.
Well, on that note, actually, it's a really good question to ask everyone who's on the call today. If you could use your chat box down the bottom, you'll see a chat box option or a Q&A option. If you can click on the chat box and let us know where you're tuning in from. It is always good to see how many people we've got from all over the world. So in the meantime, once we get people inputting that in, I just want to congratulate you, Frank, on your recent award, your Distinguished Career Award that was presented to you. Fantastic achievement. We're all very happy for you. How you feeling?
Very excited, really. That was surprising because I did apply for it 2 years ago and didn't win it. But they kept it on file and they gave it to me this time. So a couple of weeks ago in New Zealand, I received a Lifetime Career Award by the Railway Technical Society of Australasia, which is really a great thing. And one of the key reasons for getting it is the value that I've been provided to the industry via training courses and webinars like this. So you are in for first-hand taster today.
Absolutely fantastic. Well, congratulations again. And I can see we're getting a lot of people entering into the chat box in terms of where everyone's tuning in from. A couple of people from India I can see already. A lot of obviously people from Australia. So welcome everyone. Really appreciate you taking the time out to join us today. I know time is precious. In that case, I think what we'll do is we'll get things started. But before I officially hand over to you, Frank, just a couple of housekeeping things like we normally do. There's a usual couple of questions that we normally get, which is this going to be recorded? And so the answer to that question is yes. And you'll get a copy hopefully within 24 to 48 hours after this webinar. And secondly, will there be any questions? So absolutely, please do put your questions into the Q&A or chat box, and we'll take those right at the end. And for those, obviously, I don't think you need much of an introduction, Frank, but I will do a very, very quick one for everyone listening at home. So Dr. Frank Heibel is a chartered professional electrical engineer with over 33 years of international experience in railway signalling, widely known in the industry as Doc Frank. He has specialized in training and consulting for advanced communication-based signalling, including CBTC and ETCS technologies, as the most cost-effective way to improve the capacity and performance of urban and mainline railways. With that said, thanks again for your time, Frank. I'll hand it over to you, and excited to see what you have to share with us today.
Thank you very much, Fasi. Hello, everyone. Again, a pleasure to have you here. And I hope that you will find after that hour that it was an hour very well spent. And if I can already give you a little hint, you have probably once in a lifetime opportunity to work for the next 60 minutes as an hourly rate of more than $2,000 an hour. So I hope that keeps your interest awake. Let's just go to my presentations. Fasi already gave a quick introduction. I have a few additional points which may be worth mentioning. Yeah, I'm in the signaling industry for over 30 years internationally. 20 of those years I worked with global signaling suppliers, with several ones, quite well-known names. The last 14 years, I worked as an independent strategy consultant and trainer. And the reason I mention this is that I develop perspectives of both sides, of the supplier side and also the client side, which is quite a useful combination because I basically understand both sides and can help one side understand why the other side is behaving so strangely, if you will. Since 2014, I have provided trainings on modern train control systems, starting with CBTC, and then over the years developing ETCS trainings and also a number of other courses. I started off with live classroom trainings. This all fell into a heap when the pandemic hit in 2020. And then I pivoted to first the live online trainings, where I did the entire training course on Zoom calls like this one here. And then later online courses where everything was recorded and the video lessons could be watched by anyone at any point in time, anywhere in the world. What's special about my training courses and generally all the knowledge that I try to share, including the one today, is what I call a 100-100 teaching objective. What that means is that I want 100% of my students, webinar attendees, whatever, understand 100% of the content of the training course, webinar, whatever it is. So you can check for yourself as a challenge for today whether you really understand 100%. If not, as Fuzzy said, you have the opportunity to ask questions in the chat box, and we will get to those questions at the end. And if that's not enough as a motivation for you to stay until the very end, there will also be a couple of surprises, because I do have to explain that thing with the $2,000 per hour rate. And I guess you will look forward to that. So what are our goals for today? Firstly, we start learning something. So in this next few minutes or in the next hour, you will understand a definition of high capacity signaling and also why it is so beneficial for the railway industry. You will know the two most common technologies for high capacity signaling, importantly, with their main strengths and weaknesses. So I'm not just telling you the names of those two technologies and then go on, but I also explain why I think they have very different strengths and weaknesses. Then derived from those strengths and weaknesses, we develop these two key factors, what I call the two keys in the webinar title, for high capacity signaling. And again, importantly, what are the implications of knowing those two keys for the strategy when you start planning the rollout of a new signaling or train control technology? What we do then is a little check of your learning success. So I'm doing with you a little quiz. Whether you participate or not, it's up to you, but you can basically check for yourself whether all the stuff that I explained to you over the next few minutes will actually get stuck. And what you will probably find is that you actually learn something that you can memorize and remember, not just today and in the next 5 minutes, but hopefully in the foreseeable future. I just ran into a previous training participant of mine, and he could recall things from the training course after 10 years. So some of the stuff that I'm teaching really seems to stick. So I will then talk about ways to learn more about obviously we can't do a full-blown training course in an hour, but I will give you a few other ideas that you may want to pursue. And then we get to a couple of surprise gifts and the Q&A at the end. And people who have done a Q&A with me before will probably know that staying around for the very end is really worth it. So let's start with the training part of this webinar. What are ways to increase the capacity of a railway? So let's just assume this is the current service. So you have one railway line with a certain train service on there that is depicted by this one train with 3 carriages, with 3 cars. And that's demonstrate the current level of service, just to give you a benchmark to start from. So one way of achieving higher capacity, meaning transporting more passengers per hour along this railway line, is to have longer or better trains. Better means trains where you can fit more passengers in, by and large. So if you were taking the seats of a train in terms of passenger capacity, that train would become better. The traveling comfort may go down, but nonetheless, you could transport more people with that. So that's one way to do it. Another way to do it is to build additional railway lines. So you see this example here. You've got the one line which looks like the base case, and then you've got a second new railway line next to it which has a similar train service. So that would basically mean you double your capacity. What the feasibility is of building additional railway lines, especially in city centers, well, I leave this to your assessment. Often you have to go underground. It's getting very expensive very quickly. And then, of course, we have one additional way, and this is just to improve the throughput of the railway line. And this is indicated here by running not just one, but two trains on the same stretch of railway line. And this is where HCS, or high capacity signaling, kicks in. And if you compare all those options, and I've done this, but for time reasons, I'm not going to present this now, but you can summarize that high capacity signaling is the most cost efficient of all those methods for improving the capacity of a railway. So some people complain to me that this modern signaling is so terribly expensive. And I say, well, you rather want to build additional railway lines for higher capacity? And then I said, maybe in that circumstance, it's not that expensive. And I said, exactly. So let's keep talking about the modern signaling. So I promised the definition of high capacity signaling. So what is it? So firstly, high capacity signaling overcomes the limitations of a conventional signaling system. And by conventional signaling system, I usually mean something with optical line side signals, which sometimes I flippantly call lights on sticks, and also fixed block sections, which have a certain length. The length of the block sections is defined by the worst breaking train that operates on the railway line. So they can be quite long, and accordingly, the distance between trains can be quite long as well, which reduces capacity. So as a definition for high capacity signaling, and this is not a textbook definition, this is my personal definition, which I think is has a practical background. If you have an operational capacity of at least 24 trains per hour, that's a train every 2.5 minutes. That's what I would call high capacity signaling, or what I think deserves the name of high capacity signaling. Operational capacity means it's capacity that can be achieved reliably across the entire day, including in peak traffic. So it's not you can just about get it done, but only for 5 minutes, and then everything gets delayed. Operational capacity means that you can keep this up during the entire day, whenever you want, whenever you need it. So, and the way that high capacity signaling is normally provided is by advanced technologies that are often summarized under the label automatic train control. And this includes cab signaling, where the train driver gets the movement authority to drive the train on a display on the driver cab. Some capacity optimized blocks. So the block sections that I talked about in the first bullet point are now optimized for higher capacity, which in cab signaling works much, much better than in a system which is based on optical line side signals. And often these advanced technologies also come with ATO, which stands for automatic train operation. That means the computer drives the train based on instructions from the control center, and that gives a lot of more opportunities for higher capacity. So what are the two most common technologies for high capacity signaling on a global scale? So it doesn't matter where you watch this from, if you are from the Middle East, if you are from India, if you are from Europe, the two mainstream technologies are pretty much always the same. And the first one is communications-based train control, or short CBTC. And the second one is the European Train Control System, ETCS, but careful, only some advanced varieties, not just any variety of ETCS. It needs to be something special, and we will find out why that is in just a moment. So pretty much any railway in the world that wants to introduce high capacity signaling usually chooses between those two technologies. And I have been involved in various technology selection exercises here in Australia, in cities like Sydney and Perth, for example, where every time we had two candidate technologies, CBTC and ETCS, and then the decision was to be made between the two of them. So let's have a quick look at CBTC, not a full-blown introduction, because again, that wouldn't fit into an hour. But I promise to tell you the biggest strengths and the biggest weakness of each of those two technologies. So let's start doing this with CBTC. The biggest strengths, which is also the main purpose of CBTC, is the maximized utilization of railway infrastructure. Railway infrastructure means the tracks, the stations, the bridges, the tunnels, anything you need to keep trains running. How do you maximize the utilization? You send down as many trains as possible, and that, of course, translates directly into capacity. So the potential for higher capacity is clearly the main strength of the CBTC technology. And what I often do is, because I tend to invent terms that basically stick in people's memory, so I keep calling CBTC the gold standard of high capacity signaling. Because of all the globally available signaling technologies, CBTC is the one with the highest capacity potential. Let's have a look at the biggest weakness of CBTC. Nobody is perfect, and no signaling technology is perfect either. The CBTC products from all the mainstream suppliers, your Alstoms, your Siemenses, your Hitachis, and so on, these products are all proprietary, which means they're different for every supplier, and therefore they don't play with each other. They are not interoperable. And this has consequences for a CBTC rollout where you want to involve multiple suppliers. Again, I don't want to go into detail on that, but just as a side remark, if you plan a CBTC rollout where more than one supplier is involved, you need to consider these interoperability challenges. Let's have a look at ETCS. Same thing, starting with the biggest strengths and then looking at the biggest weakness. The biggest strengths, which is also the purpose of ETCS, is the potential for interoperability. ETCS was conceived to harmonize ATP, that stands for Automatic Train Protection. If you're new for signaling, just get used to it that we're using acronyms for pretty much everything. So ETCS is to harmonize ATP across Europe. There are many, many different countries in Europe. Every country has pretty much their own technology for automatic train protection. There are different technologies, they don't talk to each other. So ETCS is meant to harmonize all that. Therefore, interoperability is a key concern and also the nameplate strengths of ETCS. And therefore, it is the preferred choice for any railway that wants to roll out train control systems with multiple suppliers because of that interoperability potential. The biggest weakness of ETCS is that the main function, as I mentioned in the first bullet point, is automatic train protection, or ATP. And ATP is all about safety, additional safety. A signaling system should be safe anyway, but automatic train protection adds an additional layer of safety, but not capacity. So the capability of providing higher capacity in ETCS is in fact quite limited. It doesn't come automatically. And what it does require is an advanced application of ETCS in order to beef up the signaling capacity a little bit. Now, I'm not sure whether you noticed, if you still have the previous slide in mind where we talked about strengths and weaknesses of CBTC, it's exactly the opposite way for ETCS. So the biggest strength of ETCS is the biggest weakness of CBTC, and vice versa. The biggest weakness of ETCS is at the same time the biggest strength of CBTC. And this led me to a very interesting conclusion. And when I made this, I wondered, why didn't I get to that like years earlier? I mean, I've been researching that stuff for many, many years, for consulting work, for training courses, and so on. But I think it's a bit like you have a favorite movie and you watch the movie, you liked it a lot. You say, oh, I'm going to watch it again in 3 months or so. And then you watch it a second time and suddenly you notice a few things that you've said, I can't recall I've seen that the first time. Yeah. And then later you watch it the third time and again, you pick up something new. So that's kind of the effect that I had here. So coming from this overview of strengths and weaknesses, I basically came up with two common themes for both technologies, for CBTC and for ETCS. And the common themes, or what I call here the two keys or key factors, if you like, are capacity and interoperability. So, I drew up these fancy two keys, one with a C for capacity, and then there's another key with an I for interoperability. But what's important here is that the order of importance, which of those two keys is more important, it differs between CBTC and ETCS. And this has consequences on the strategies. So the strategic thrust for CBTC will be different than for ETCS, which many people may not understand. Until now, you do. So what are the key strategic priorities for CBTC? Well, first and foremost, you need to deal with that lack of interoperability. Because if you don't do that, whatever you do with CBTC will fail 100%. Yeah, so you need to address this lack of interoperability. You need to do something about it in some shape or form. There are various strategies how you can do it, but that needs to be addressed first. And then secondly, you need to make sure that you actually get the maximum output of the capacity provision that CBTC as a technology gives you. Now, for ETCS, guess what? The order is exactly the other way around. So for ETCS, firstly, you need to see that you push as hard as possible for higher capacity. And one way to do it is to make it look and behave as much as CBTC as possible. Because remember, CBTC is the gold standard for higher capacity. And then the second priority for ETCS strategies is to make sure that you really get interoperability. And it's not quite as simple as some people may think. So if I try to give you a common pattern for the strategies for both technologies, it would be first address the biggest weakness, and then secondly, secure the strengths. So make sure that you really get the most out of the strengths that the technology gives you. So quiz time, ladies and gentlemen. Let's check your learning success, how much you can remember from the previous few slides. And well, I wish you all the best. I hope you remember everything. And if not, then it's maybe time for a question in the chat that we can discuss later. So first question, high capacity signaling means providing at least how many trains per hour operational capacity? And the answer is 24. Question number 2, the most popular global technologies for high capacity signaling are, and there are 2 gaps, so I'm waiting for 2 answers. I can't hear you, so I guess you probably have it right already. The first one is CBTC and the second one is ETCS. Next question. The biggest strength of CBTC is maximum potential for? That's right. Capacity, one of the 2 keys. And the biggest weakness is, well, the other key, as you may remember. So it's the lack of interoperability between suppliers. It's not that hard, is it? So if you have done everything correct so far, then you have definitely learned quite a bit that you may not have known when you joined the webinar today. To me, that's a success. I hope you see it the same way. Next one, the biggest strength of ETCS is its potential for, and yes, it's the same answer again, interoperability. And the biggest weakness is that it was not meant to increase capacity. So if you think that's trivial, then think again. There's a lot of profound stuff in here. And the key thing really is for you to remember it. And if you say that's very, very, very easy to remember, fantastic. This is how it should be. Next one, the two keys to high capacity signaling are, number one, addressing the biggest weakness, and then secondly, maximize the biggest strengths. And this approach, this generic approach, weakness first, strength second, is the same for either CBTC or ETCS, but because they have the inverse relationship of strengths and weaknesses, it turns out that the practical strategies for CBTC and ETCS are different. So if you want to learn more about these two things, these two keys, how can you do that? Well, as it happens, there is a training course available how to achieve your capacity targets, because there are examples for both CBTC and ETCS where the client organization spent a lot of money for the new technology, but then ended up very disappointed with the actual outcome regarding capacity. So the training course here is called High Capacity Signaling Blueprint, and it does exactly what it says. It provides a blueprint how to get to real practical high capacity signaling. The other thing is how to address interoperability, and there is also a training course which is called Digital Signaling Interoperability. And in case you wonder why I mentioned those, both training courses are mine. So you will get more of the kind of training that we have had for the last few minutes if you were joining any of those two training courses. Now, let's have a look at the first one, the High Capacity Signaling Blueprint. It is the only training course on this topic in the world. It's hard to believe, but that's the case. I did a search just recently, and as a modern person in 2025, you start searching in ChatGPT, of course, and this is what it tells you. So you ask the question, who offers training on high capacity signaling? And the answer is that this training that I just mentioned, the blueprint, is really the number one. And at the very bottom, you will see it's the only known training course that focuses on high capacity signaling in the world. And if you kept searching, there is not really a number two. There is nothing else. There are some more generic signaling trainings that are also offered there, because ChatGPT probably thought, well, I can't really give only one answer, even though there is only one. But this is what happens. And if you take a different search tool, if you take Google AI, for example, guess what? You get the same answer. There is actually, Google was a bit smarter there. They actually recognize that here in Perth, we have a project which is called High Capacity Signaling, and they have a training center where they offer some training for tradies, for signaling technicians. So it's all about installing stuff in the field that is related to high capacity signaling. But that's obviously very specific to the location here. And if you want to understand more the theory and the generics of it, then yeah, there's only the one training course, which is mine. So this course, as all my trainings, is suitable for beginners and for advanced railway professionals alike. So some people take my foundational trainings on CBTC or ETCS, and then they take this one as the next step, the advanced step. And some take it as a standalone training and say, well, I want to learn something about signaling. So my railway is going into this high capacity signaling thing. So why not learning something about this to learn the right thing just from the start? The course goes over a period of 4 weeks, or it's planned for a period of 4 weeks, and the next one starts, or the first one actually starts on the 22nd of September. You get weekly drip feeds of content, so we're not overwhelming you by dropping everything at once on you. We are doing this like step by step to manage your workload and make things easier for you. The total duration of the video lessons is more than 8 hours. So for those of you who need to demonstrate CPD or continuous professional development with all the additional quizzes, exercises, and live sessions, I'll talk about this in a moment, there will be 10 to 12 hours from this training course that are eligible for your CPD records. For some people, that's quite a strong argument. There are workbooks provided with the training. There are knowledge checks similar to the one that we just did a moment ago. There's a discussion forum for continuous question and answers with me personally. And this is really a very outstanding feature, I believe. So often enough, you have an online course and yeah, you get the lessons, but then you have a question and yeah, there's nobody there to answer it. Well, that's different here. So you've got a discussion forum. It's kind of similar to a Facebook group, but specific for this training, where you can post a question at any point in time that you like. And I will be the only person answering those questions personally. And actually, just a few minutes before this webinar started, I answered a few questions that participants had for my ETCS training. And wait, there is more. There are also 2 live interactive sessions where you can basically see me like this on a Zoom call face to face, but I can also see you. That's different from this setting here. And you can ask me questions face to face and we can discuss things back and forth. Really great things. They take about an hour and 2 of them will be offered in the 2nd and 4th week. And if you were wondering why further up in the slide, I said 10 to 12 hours eligible for CPD. That obviously depends on whether you can attend those live interactive sessions as well, because each takes an hour. So that's basically the difference between about 10 hours and about 12 hours for CPD. So what's the content of this training? Quick overview without too much detail. We talk about definitions in a bit more detail and also the economics of high capacity signaling. So all the stuff that I couldn't cover today will be covered in this training. We talk about how to overcome signaling capacity constraints. So the theory behind why does signaling have a constrained capacity and what can be done to overcome these constraints. We then talk about CBTC in much more detail, why this is the gold standard for high capacity signaling. So what are the CBTC features that actually provide high capacity signaling? We talk about ETCS and what the specific varieties of ETCS need to be for providing high capacity signaling. Some people said, well, that doesn't work with ETCS. Well, that's wrong. You just need to apply it correctly, and you will see how that's done in this training course. And then we look at both technologies at the same time, and we say, okay, well, if you have to choose between the 2, when do you use actually CBTC and when do you use ETCS? So that's basically like 2 years of work in, yeah, I don't know, in a couple of hours or so. Defining a high capacity signaling solution, if you choose CBTC or if you choose ETCS. Then we talk about supply strategies and some suitable operational concepts. And then we talk about delivering high capacity signaling without service disruption. So depending on where on the journey you are with introducing that new technology, or the railway you're working on is regarding those new technologies, the insights from this training course can literally save you millions of dollars and years of effort if you apply them at the right point in time in the correct way. Obviously, that's not a promise. I'm not allowed to do that. It depends very much on what you do with the information you get there. But just saying, some people have been very, very, very happy with the outcome of this training. So talking about interoperability, the second big topic, it's currently very trending here in Australia, and I'm guessing that most of the people on this webinar will be from Australia. So you may have heard that just a couple of weeks ago, there was a meeting of all the transport ministers, the federal one and also the state transport ministers, and they talked about interoperability. And they decided that ETCS, the European Train Control System, will be the technology of choice for the so-called National Network for Interoperability here in Australia. So you see that interoperability is a very hot topic here in Australia, and it will remain a hot topic for the foreseeable future, for the next 10, probably more years. So let's have a look at the training course, Digital Signaling Interoperability. And guess what? Again, it is the only training course on the topic. Try to find another training on signaling interoperability, you won't. And again, I did some of the legwork for you. So that's a screenshot of the search result from ChatGPT. Again, it mentions my course, and if you went further down, there is really nothing else coming out. It is really the only training which is specific to interoperability of signaling systems. And here's the search result of Google AI. Again, it mentions my course that I'm doing with the Informa Connect Academy. And then it also mentions the National Transport Commission here in Australia. They, of course, look into interoperability. So they're planning for interoperability, stuff like that. They're not providing trainings. So, but it's still good to know that. But as far as training goes, this is the one course that you can choose from. And it's a pretty good one. So again, it's suitable for beginners and advanced professionals alike. So if you are what I call a non-signaling person, you will understand everything in this training in the same way that I hope you have understood everything so far in this webinar. Again, it's a 4 weeks training that starts 1 week later, so that we basically have a bit of a shift between those two trainings. And again, there's a weekly content drip feed. So the concept for both trainings is the same because it's just good, it works for people. The video lessons are slightly more than for the other course, but not very much. So it's just a few minutes more. It's closer to 9 hours. So again, I think eligible for CPD, if anybody asks me, anything between 10 and 12 hours, depending on whether you attend the live interactive sessions or you watch the recordings. That's another way of doing it. Then you can basically record up to 12 hours for continuous professional development without blushing and with good justification. Again, there are workbooks and knowledge checks, a discussion forum for ongoing Q&A, and 2 live interactive sessions in the 2nd and 4th week of the training. So, quick overview of the contents, some key definitions. I always like to start my trainings with definitions so that everybody understands what we're talking about and we are on the same page. Then I'm talking about the SPA framework, and this can really be a game changer that takes you from confusion to clarity. I have seen so much confusion about this interoperability stuff in the marketplace, even with experienced signaling people. It's not funny. And that's the reason why I came up with a framework that really makes things very, very easy to understand. And you will understand the entire landscape of digital signaling, either in Australia or worldwide, much, much better with that simple 3-letter framework. We then look at the digital signal landscape in Australia, not just because I live here, but because Australia really is a showcase of many different technologies for digital signaling. So as far as interoperability goes, it's a beautiful case study for any country in the world. We then introduce 3 digital signaling technologies. Well, unsurprisingly, CBTC and ETCS will be part of that, but there's also a third one we will be talking about as an example for anything that's not CBTC or ETCS. We talk about interoperability challenges, facets, and control options. And again, there's more to interoperability than meets the eye, and understanding more comprehensively what interoperability is about will be a real eye-opener for you and will help you tremendously in your career if you are in a position where you have to do with this kind of interoperability. So we then talk about interoperability within a technology. So within CBTC, what can be done to address it, and within ETCS, how to get there. And then we talk about interoperability between different technologies for digital signaling, if, heaven forbid, that be a requirement for your railway. And then at the end, we look at some typical questions regarding interoperability. So thank you very much for staying to the very end. We're not done yet because I did promise you a special surprise. I'm really keen for you joining one of those 2 training courses. And because it's the first time that I'm running those trainings together with Informa, I wanted to give you something really special. And this is something that I have never done before. And it's a one-off gift. This training these trainings will run again next year in 2026. But this offer here is for these next 2 trainings, from the 22nd of September for the high capacity one, and from the 29th of September for the digital signaling interoperability one. And this special offer for you is what I call Doc Frank's Project Clinic. So my nickname is Doc Frank because I'm actually a doctor. I have a doctorate in electric engineering, not in medicine. But as doctors may do, at times they do a clinic. And I want to do with every participant of those 2 training courses, only this time, a so-called project clinic. So this is exclusively for all of you that sign up to those next runs of those 2 training courses. Not any other trainings, not next year, not it's now or never. It will be a 3-hour workshop on Zoom where we can actually see each other. So your camera will be on as well. So it will be much more interactive than what we're doing here right now. And this workshop will be done the week after the second of those trainings have completed. So when both of these courses are done, that's the week starting on the 27th of October. And on Thursday, the 30th of October, we will have that workshop, the project clinic, at a later time in the day, which I hope also suits participants from Europe or from any time zones which are a bit behind Australia. So the starting time is 5 p.m. in the afternoon, daylight saving time in Australia. That's the Melbourne, Sydney time zone. And then you can calculate what the starting time will be in your zone. So what we want to do in this project clinic is basically free consulting. And that's why I said I've never offered this, and I'm normally not a fan of providing free consultancy, but I will make an exception here in this workshop. So what I want to do with you there in those 3 hours is to provide consulting for case studies that are provided by any of you, the attendees. So you can basically make proposals, what you want to talk about. These proposals can be real, so real issues that you have with your railway where you would like to get my opinion or my help, or it can be fictional. So you can basically make something up that's really up to you, as long, because you may say, well, for confidentiality reasons, I can't really talk about my railway. But if we had a similar railway somewhere else, which has a very similar problem, how would we address this? So however you want to play this, really up to you, but it will be 3 hours of massive value with free consultancy. So the value of this, roughly from my hourly rate of what I would charge for this type of consultancy is $1,800. And this will be free for you if you register for those training courses. So that gets you already pretty close. If you were taking me up on this offer, you would already have made $1,800 right now. And there's a second thing here. You can also get a 10% discount from Informa. So that's their gift to you for staying around until the very end. And this 10% discount, because Informa are very nice people, is not just for the 2 training courses coming up now. And you see all the start dates of my 7 training courses that I'm doing with Informa here on that overview slide, which I will leave for the question and answer session as well. You see the links where you can register, and you also get contact details of a very nice Irish guy, Dean Devereux, who would happily sign you up or give you advice on any training needs that you may have in that field. So with all of that said, I hope I could make it attractive for you. One, to show you that you could actually understand and learn something about high capacity signaling just in these few minutes during the webinar. And secondly, I hope I could also whet your appetite to learn a bit more, and it would be my utter pleasure to see you again at one of my training courses. With that, I'd like to hand back to Fuzzy if he is still there and listening to me, because now we are having question and answers. Feel free to stay around. Normally my Q&As are very, very informative. If you need to go somewhere else, then thank you very much for being here. It was a pleasure talking to you, or at you, if you will. And yeah, and I really hope that we see each other again in one of my training courses. And then because of the live interactive sessions, we will actually get to see each other face to face. Thank you. Back to Fuzzy.
Thanks very much, Frank. That's first of all, thank you for taking the time to walk us through those details around the 2 technologies, and also for doing my job for me, which is going through those details on the courses that we do have. You're always making my life easier, Frank. So thanks again for doing that for me. But just to recap, on behalf of Informa, we do like to think of ourselves as being quite nice, and as a thank you for everyone who is hanging around, we are offering that 10% discount. And to register, please contact my colleague Dean on those contact details you can see on your screen, either through phone or through email. With that in mind, as we've just discussed, Frank is very happy to take questions, and we do have a couple already ready to go, Frank. So I'll take them in chronological order. So I'd like to perhaps ask Alina has asked this question. She's asking, is the reason ATO is required for high capacity signaling systems mainly due to the ATP braking curve? Is not drivable for humans drivers? I'm not sure if that makes sense. Let me, did that question make sense to you, Frank?
It does, absolutely. Yeah, the question makes a lot of sense. It's a good question. Well, firstly, you don't have to have ATO for high capacity signaling. Obviously, if you choose to take CBTC as a technology, then ATO is a given feature which comes as part of the package. So you would struggle to have a CBTC without ATO. Yeah, it's really a downscaling of functionality. So for CBTC, ATO would be a given. For ETCS, it's an extra feature which you don't necessarily have to have. You can get higher capacity without ATO. ATO is an additional feature that can help you to get yet a bit more capacity. The reason is not just the related to the braking curves of ATP, so that's a pretty intelligent assumption already. The thing that ATO does, if it's well designed, it provides the best possible driving profile each and every time. See, when you have human train drivers, they have different driving styles, and there were studies out there which showed that the variety between different train drivers in journey times are significant, up to 100%, which means that the slowest train driver takes twice as long as the fastest train driver. It's unbelievable. I could not believe my eyes when I saw it the first time, but the studies are really out there based on practical measurements. So what ATO does, it basically reduces those variability of driving styles, and every train run is perfect for every train. And that's the main thing, how ATO helps with higher capacity, because you can take a lot of buffer out of the timetable, and that means you can bring trains closer together, and that means higher capacity.
Interesting. Very good. Again, a reminder, if this is a great chance, if you do have a question, please put it in the chat box. Next one is from Jagindra, I think. My apologies if I mispronounced your name. They're asking how it is determined that 24 trains per hour is considered high capacity?
That's a good question. I thought when I developed this training course, and I thought for defining high capacity signaling, there needs to be a line in the sand. There needs to be a number, yeah, and it needs to be a number that is higher than what you can achieve with conventional signaling, because if you can achieve it with conventional signaling, then you don't really need high capacity signaling, right? So with conventional signaling, rule of thumb, and there are some exceptions, but rule of thumb is that at around 18 to 20 trains per hour, that's the end of the line. Yeah, so unless you do something very fancy with multiple platforms or something like that, so any extra tricks with more infrastructure, the pure signaling capacity for conventional signaling systems usually has a ceiling around 18 to 20 trains per hour. So this 24 figure needed to be higher than 18 to 20, and it is. And at the same time, I was looking at all the different examples for modern signaling, for advanced signaling that we have here in Australia. And if I had said the limit, the lower limit for high capacity signaling is, say, 30 trains an hour, I would have discredited a number of projects in Australia where they say, oh, wait a minute, we're doing high capacity signaling as well. And by the way, it's not just Australia, it's in other countries as well. If I think of the London Thameslink project, for example, they were introducing ETCS with ATO for higher capacity, and they are running 24 trains an hour. So this is basically a benchmark from my global experience, where you can say, okay, well, this is where you can get to with high capacity signaling, which is above what you can achieve with conventional signaling. This is where the 24 comes from. And as a consequence, we have a number of projects in Australia which qualify to be called high capacity signaling. And I think people will say, yes, that's absolutely justified.
Very good. So the next one is a bit of a long-winded question, but I'm going to ask you to bear with me just because I think it is an interesting question to answer, Frank. So the background or the context is this person is asking, CBTC is undeniably proprietary and vendor locked, yet the Queens Boulevard line in New York stands as one of the first real examples of an interoperable CBTC deployment. At first glance, the strategies behind such projects may appear straightforward and palatable, but the reality is far more complex. It's worth noting that even legacy route relay interlocking systems have historically supported high train throughput per hour than some SSI CBI-based deployments currently operating in Victoria. So the question is, this raises a fundamental question. What guiding principles should drive investment and decision making?
I love the question. I love the question because it's about New York, and whenever the topic CBTC interoperability comes up in a discussion, somebody will say, "Yeah, but what about New York?" And so New York came up with a plan for interoperable CBTC in the late 1990s. So they officially started their program in 1999. And the planning looked very good, very straightforward, as you said in the question, straightforward and palatable. The implementation wasn't quite that easy. So number one, the first two CBTC projects in New York, one with the first supplier and one with the second supplier, according to a joint specification of interfaces between both suppliers, are the two most expensive CBTC projects that were ever done anywhere in the world by a long way. So that shows that whatever New York did, they ended up being successful, but it was very, very painful and time consuming, and nobody else basically wants to bother doing it because it's just too hard. And what maybe the saddest situation is that the solution that was developed for New York, where you now have interoperability between actually 3 CBTC suppliers. So we had interoperable interfaces between 2, Siemens and Thales. And then there was a third company coming from Japan, Mitsubishi. They said, oh, we want to develop the same interoperable interfaces in our CBTC product. And New York said, well, yeah, why not? So now they have 3 suppliers and they are interoperable. But this solution is so bespoke, it's so New York specific, that none of the suppliers would want to transfer it anywhere else in the world. So if you were asking the question, and I know because I did ask that question for Perth, for example, I asked the suppliers, can we have the New York solution implemented in Perth in Australia to achieve interoperable CBTC? And none of the suppliers was willing to do that. They said, no, 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 that's the New York solution. Let's park this. This is not usable anywhere else. So if any other metro, and I think you did mention Melbourne in the question, if Melbourne wanted to do something like that, they can basically prepare themselves for about 20 years of hard work and a lot of pain and a lot of expenses. And yeah, and they may be best case as successful as New York, worst case they may fail entirely. And then yeah, I would not recommend this to anyone here in Australia or anywhere else in the world for that matter.
Very interesting. There's maybe 2 or 3 more, Frank, if you're willing to be with us.
Yeah.
Alina actually has a follow-up question, I think. So she's asking, would CBTC system likely to deliver a signaling system where the ATP braking curve is not drivable for drivers? In many cases, we've seen drivers of CBTC GOA2 systems not able to drive the train in degraded mode.
The answer to that is no. The braking curves that are designed in CBTC, unless the design is completely screwed up, but this is normally not what happens. Suppliers of CBTC systems normally know their stuff and they know what a train can physically do or not. There are certain braking rates that a train has, and those braking rates are reflected in the driving profiles, including in the braking profiles. So what CBTC does in driver-supported operations, so you mentioned GOA2, that's great of automation too. That means that the system, I mean, in GOA2, it's still the computer driving the train, right? So, and then you were mentioning a degraded mode. Degraded mode means, for example, ATO doesn't work and the train needs to be driven manually, but it's still supervised by the ATP system of the CBTC. Well, the ATP system will provide a driving profile and will indicate to the train driver what the train speed can be at any point in time. And then the train driver can react. And the train driver will be able to react because whatever the system suggests that the train driver does will be achievable, provided that the train driver reacts in time and so on. So the I have never encountered it anywhere that CBTC came up with driving requirements that a human driver could not fulfill. It just not. I mean, at the very worst case, if the train driver really can't keep up for whatever reasons, then the system would take over by applying emergency brakes, which is not nice, but at least it's safe. But normally the driving profile should be absolutely manageable for train drivers.
Very good. Some very interesting questions coming through, Frank.
Oh
Another
yeah,
one
yeah,
that,
yeah. I like them a lot, all of them. Yeah.
Yeah. This one's a little bit more training course specific, but it's a good question to ask, I suppose. Pradnesh, I think the name is asking, for non-signaling background professionals, how does this training help to get entry to the signaling job market in Australia? What are the criteria for engineers to get jobs in signaling?
It's not, I don't want to overpromise. It's definitely not a firm requirement. I would be extremely surprised if you apply for any job in Australia and somebody says, well, as an entry requirement, you need to take one of Doc Frank's training courses. This is not happening. Yeah, so let's just be real about that. If you apply for a signaling job anywhere, not just, I don't want to fix it to Australia, I think it's the same situation everywhere. People will ask you justifiably for your qualifications. So what do you know about the subject matter that you want to work on, in this case, modern signaling? And then it's not so much that you can basically show a certificate that I have attended a signaling training, not just my signaling training, any signaling training. That won't matter so much. But the stuff that you will have learned during the training should help you doing the interview, should help you answering questions. And I can give you a practical example. A project manager from outside Australia, he said, well, I've worked in civil projects all my life. In my hometown, there's a big CBTC project coming up. I want to work on that. So would your CBTC training help me? And I said, well, it would certainly not make you dumber. So why don't you try? So he did my CBTC training. He then did a certification. I'm also offering separate certifications of CBTC knowledge, where you can basically get certified that you demonstrate a certain knowledge that you get from the training. And then a month later, I got an email from him and said, hey, I got the job. I got the job on the CBTC project. And well, was it just because of my training? Probably not. I mean, if somebody just behaves stupidly, then yeah, there's not much that the training course can do. But what he did report back was that he obviously got questions in the interview about CBTC. Thanks to the training, he could answer all those questions very satisfactorily. And then I said, well, how do you know so much about CBTC? Because in your CV, you don't really have CBTC background. Then he said, well, I've done this training course with Doc Frank. And he said, yeah, with Doc Frank, we know he's doing CBTC trainings, one of the few in the world doing that. So long story short, it's not the fact that you attended a training course which will help you. It is the knowledge that you gain from the trainings that will help you by simply enabling you to demonstrate more knowledge in the job interview. So I'm not sure whether that helps you in any shape or form. And it's certainly not a free ticket for a visa to Australia. That's one thing I can promise you. So if that's your expectation, then that's probably a bit over the top. But definitely, I would think that the training course, if you learn everything that I would hope that you learn in these trainings, will certainly help you being a better candidate in any job interview in the future, and also in an existing career. I mean, obviously, if you already work in signaling and you try to qualify for the next position, or you just do a better job at work, that will help you as well.
Very good. We might do two more if that's okay with you, Frank. Again, some really good questions left. So Karan is asking, if you talk about the operational headway of 2.5 minutes, what would be the design headway, considering design headway never matches the operational headway?
That's correct. And it's another good question. I really like your questions, guys. Really, really intelligent questions. I really love it. So as you rightly said, the design capacity usually needs to be bigger than the operational capacity, simply so that you have a capacity reserve in case of minor delays that you can catch up again. As a rule of thumb, the capacity reserve for a conventional signaling system is round about 20%. If you have automatic train operation, that reserve can be reduced to somewhere between 10 and 15%. So let's just assume we do have ATO and we squeeze the maximum out of it. That would be a 10% capacity reserve. So that means for 24 trains an hour operational, your design capacity would be probably 27 trains per hour, which is just a little bit more than 10% reserve. And 27 trains per hour, the inverse would be the headway, which is, I don't really know, somewhere like 2 minutes and 10 seconds or 2 minutes 15, somewhere in between 140 and 130 and 135 seconds or so, I guess. So that would be the answer. So you need to have a higher design capacity. That's very important. If you don't have a difference between your design capacity and your operational capacity, you can expect a very poor performance against the timetable, because you have no reserve to catch up with any kind of disturbances, minor delays. Everything will just keep building up and you can't recover from it. So therefore, you need a capacity reserve, which means design capacity needs to be higher than the operational capacity. Great question, great question. And I hope what you guys have all seen, that in those Q&As, depending, of course, on the quality of questions, there is additional stuff that was not mentioned in the training or in the webinar that you can take away as additional learnings. I did tell you from the start, so there's the proof.
You certainly know your stuff, Frank. There's no doubt about that for sure. Before I get to the last question, there is a comment from Sinan, just to offer some additional context or perspective from his point of view. I won't go into actually reading that out. It's quite a long comment, but it is in the chat box. So if anyone is interested, and Frank, if you'd like to have a look at it at some point. But just to wrap up, though, I think it's only right that we give Alina, who has come back with a third question, the last question to ask you before we wrap up. So Alina is asking, regarding train-to-train communication, also referred to as train autonomous control system, or otherwise train-centric CBTC, like Alessimo achieves operational headway of 66 seconds. I think that's what you're saying. Curious to know, I think, TACS versus Verbalize Fluency, which performs better in this competition? Well, I think she's saying, so like Alstom achieves operational headway of 66 seconds. I'm not sure if TACS VS, Herbalize, or Fluency means much to you, but she's asking which performs better in this competition.
I'm trying to find that thing in the
It's the last chat. Question, last comment in the chat box.
The last, okay, good. Then okay, good. So I can't really say much about the Chinese system, the TACS. I heard about it, but okay, let's have a quick look, because I wasn't quite sure, Fuzzy, whether I really understood everything correctly. Well, okay, so yes, there have been very few examples on vehicle-to-vehicle CBTC, with the attempt of reducing the wayside infrastructure of CBTC, bringing more intelligence on the train. So basically trains communicating with each other, and also trains communicating with trackside infrastructure, for example, switching points in a certain direction or so. what I found interesting is that those systems haven't really got much traction. So the Alstom example, the Obalis Fluence, has been advertised for many years. I'm not aware of any reference other than one project in France. And if a product is around in the marketplace for so many years, but it's not being sold anywhere, that makes me suspicious. I'm not saying there's anything wrong with it. I'm just wondering if this is really so fantastic, why isn't this used much more in the world? So maybe there is something wrong. And as far as this operational headway of 66 seconds is concerned, if you don't stop trains at stations, you can achieve pretty much anything with any signaling system. So the 66 seconds is yeah, sounds very impressive, because if you think about it, this is probably something around 50 trains an hour or even more than that. But you could probably achieve operational headway like this with pretty much any CBTC technology, simply by not having trains stopping at stations, for example. So yeah, I don't know. I mean, my personal opinion, and I would probably get into hot water with some people from Alstom there, but I don't really care, because if they can't convince me of the opposite, then I may actually have a point. As far as I'm concerned, a system that has only been applied once in the world after so many years, I would still consider experimental, with all due respect. And if I was to advise any of my railway clients on technology to be used for CBTC, and I have a vehicle-to-vehicle system on the one side that is all but unproven, and on the other side I have conventional CBTC architectures with reference lists as long as my arm, I would know what to recommend and what not to recommend. So there's not much more I can say about that. The concept is interesting, and yeah, and if I would get to see more applications of this anywhere in the world, then yeah, it's I may be convinced otherwise, but in the meantime, I would make it very clear to a railway client of mine that using a system like this would make you a guinea pig. And if you don't want to be a guinea pig, then go for mainstream.
Mm. Well, I mean, that's been a really engaging set of questions. I think, Frank, I really appreciate you taking the time to provide those answers to all those questions. And obviously, these are questions that you haven't seen before. So on the spot, on the fly, be able to answer those. That's, again, really impressive and demonstrates your expertise in these
Yeah, well,
areas.
if you do it long enough, I'm still to see a curveball question that I really can't answer, or where I don't have an opinion on, at least. Yeah.
Absolutely. Well, I think with that in mind, I think we'll wrap it up there. Frank, thank you to everyone who has hung around right until the end, and to everyone that did attend the majority of the webinar. It's been fantastic to hear your expertise in practice again, Frank. One last time, there is those dates available there for people to register to attend and see Frank in action with all those courses that we do have coming up. And as you can see with these Q&A, he obviously definitely knows what he's talking about. So thank you so much for your time and for your energy in this webinar, and hopefully we will see you again very soon, Frank, and to everyone else, thanks for attending, and have a great rest of your day. Thank you very much.
Thank you. Bye bye, everyone. Bye.